For our keynote session 2, we are having Mr. Sandeep Udmae, and he will be talking about role of AI in manufacturing industry today. Briefing about Sir, he has done his BE in engineering, MTech in computer engineering from Dr. Babasaheb Ambedkar Technological University, Lonere, Raigad, and PhD in data analysis using experience of working as an assistant.
हॅलो हा त्याचा
number one priority. This powerful tool can help you visualize, summarize, and analyze complex data in your Excel or Google Sheets and go from a boring spreadsheet like this to insightful and actionable reports.
Good morning, all. Good. So I am Sandeep Sambhaji Udmale. We are going to talk today on what is the role of AI in the manufacturing industry. When we talked about the manufacturing industry, we know that there are lots of revolutions comes in the manufacturing industry. We are currently enjoying the evolution 4. Anybody knows first 3 revolutions which has happened in the human history? The first was from the steam engines which came into the picture. Second was electrical power, and third was the computing, that is our computer, the information technology, electronics and information technology. And the fourth is a industrial 4.0 or industrial IoT. So slide number 1 please. Next slide. Okay, thank you. In 2011, Germany has proposed the 4th revolution of the industry, that is called as Industry 4.0. What is the basic fundamental behind the Industry 4.0? I hope people are aware of IoT, Internet of Things, right? Whenever you take the principle of IoT on a manufacturing industry, that gives rise to industrial IoT or industrial Internet of Things, and that is nothing but Industry 4.0. That is the fundamental basics definition. Whenever you apply the principle of Internet of Things on a manufacturing industry, that become Industry 4.0 or industrial IoT. If you apply same principle of IoT on animal monitoring, that is industrial animal IoT concept is coming, AIoT or IAOT. So whenever you apply those fundamental principle of IoT to in any other domain, that will give rise to that kind of a domain. Now, when we talked about the necessary of Industry 4.0, that basically objective is to improve the industrial organization. Whatever the current industrial organization is there, we want to have more precise and automated systems. And to achieve that thing, the Industry 4.0 has come with the cyber physical systems, that is called as CPS. Why this CPS came? First advantage of this CPS, they are decentralized and they have a capability of taking an autonomous decision, which means that they can interact with the environment, they can perceive the information from the environment, and based upon that they will think, or they have some processing, so we call it as a thinking, and based upon that they will take a decision. The advantage of this, that increase the efficiency, connectivity, productivity, scalability, transparency, safety, along with this saving the time and the money. First three terms are fine, or few terms are fine: efficiency, connectivity, productivity, scalability, transparency, safety. I hope you have read the news. Somewhere you find some of the boilers are expired and the human losses are there. In some industries, some incidents has happened. Sometimes suddenly accidents happens, and because of that, few people lost their lives. Why this happens? Because they don't have proper monitoring systems over there. Can we save those lives? That is the first thing. Therefore, that safety is very important. Along with that, saving the time and money. Whenever any production is going on, and if you think it suddenly stops, it consumes these times, as well as there is a financial loss to the industry, and they don't want to do that. They want everything in it should be run continuously, and you should maintain those activities properly. Lots of bigger plants or the larger plants in the industry, not only in industry, but if you go to the nuclear plant also, BRC, one of the nuclear plant in Mumbai, they have the automated system. If something is happened, they have to shut down their plant automatically. So in such a kind of cases, we want a machine should capable of thinking itself and take a decision. So the CPS is one of the important component basically in the Industry 4.0 or in IoT, which has a capability to think. And how they do that? They have interactive sensors, so they interact with the environment, whatever the environment is there. So lots of sensors are there, so they can interact. They have the intelligent control unit, like we can say the Raspberry Pi or something. You are aware of that thing. You can think on that. And basically a networking resources, because we wanted to communicate, because the connectivity should be there, so we want to communicate. For the communication, we want the connectivity resources, and based upon that they interact with the real world. That is the fundamental things behind that. Next slide please. Now this is the only I'm talking about, this is the turbine systems. One turbine systems. In industry there are lots of turbine systems. Why this picture is there? If you see how many sensors are there in one turbine, I'm talking about one turbine, this many sensors are there. Now if I multiply to 100 turbines, all turbines, 100 turbines will throw that much sensory data. Everyone has a smart mobile, right? How many sensors are there? In one mobile, how many sensors are there? Initially we have, in our colleges, we have that small Nokia mobile. You don't have that smart mobile. Why it is smart? It has a sensor, right? No? Lots of sensors are there and people do lots of activity on that. We almost have 5 to 6 sensors in our mobiles. So if you see over here, for each component there is a sensor attached to that, which has a capability, or the role is defined for that sensor. You look towards that activity of that machine and you capture the real-time continuous data to monitor the machineries, because those are rotatory machineries or automatic machineries. They are applied to particular application and they should run continuously. And when they are running continuously, we know that if this machinery, when they run continuously over the period of time, the tear and wear happens and the life started to decrease, because any problem can occur. So these are the sensors: vibration, air gap, tactometer, pressure, flow. Lots of sensors are there. If you see amongst them, the vibration is a very important sensor. We are going to talk about that now, because it has been connected to the lots of places. Next slide please. So as you can see, there are lots of sensor came. Why this has happened? When we say the technology is changing, the technology is not changing in a one direction. There is a back end, there is a reason for changing in the hardware also. If you see, in our time we work on P4. Then when I graduated, that time dual core came, and when I joined to the VJTI, that time i3 and i5 came. And my personal interview was happened on i3 and i5 only in VJTI. They asked me the complete architecture, what is the change, because you have learned P4. When you graduated, it was dual core, and now it is i3, i5. And now if you see, there are lots of changes are happening. Along with that, sensor technology has also changed. Hardware platform has changed, sensor technology has changed, and other software technologies which is required also change. And because of that, the i4 has modernized machineries which has installed all the sensors. Automation has increased. How the automation has increased? Because lots of sensors are deployed, and because of that the automation has increased, and with the help of latest technologies. And why the automation has increased? Because the degree of precisions we want. Now when we talked about this highly intelligent mechanical equipment basically which are used in the industrial system, because of this automation they become more complicated, and under the circumstances we have to monitor their health monitoring is required. One of the important thing, cyber physical system generates lots of real-time data. With the help of that real-time data and the artificial intelligence mechanism, can I monitor those manufacturing machineries which are used, and based upon that I can take a decision. And what is the decision? Basically, what is the root cause of a particular item is happening. So if I know the root cause, then based upon that I can take a decision. For example, I will tell you one of the experiments which we have done with the Magit India, which is one of the leading sensor company. We have done the experiment on whether the components are properly fit or not. The components are properly locked on the machine or not, a particular large machine. If it is not locked, it will give the vibration straight away. That is called as misalignment. If your machines are not properly aligned, they will give the misalignment will happen, and those misalignment nothing but the vibration will happen, and that vibration need to be captured so that you can tell there's a misalignment. So that kind of a root causes we need to find out, and if there is a misalignment, then there is a wear and tear between the two components starts, and that will damage the further equipments. So that is the one of the reasons we should identify. And amongst this, one of the important component when you talked about the rotatory machine is bearing is the important component, because in industry near about 45% machine fails because of the bearing. Everyone aware of the bearing in our? When you come to know the bearing is failed, when you listen the noise, when the noise comes from the fan, which means that the fault has already started few days or few months back. When your ears hears that thing, then you come to know there's a bearing fault. Similarly, everyone has traveled by the train, right? Express train. If you imagine express train, or if you analyze the express train properly, or you observe that thing, the size of the coach is very fixed. Why? Do you have that answer for that? Why the coach is very fixed? Why there is no variation in the coach? You go all over India, the coach size is very fixed. Not only that, the wheel position is also fixed. There are 4 wheels only, front at 2 and the back at 2. Other than, we don't have that more than 4, but the position is also fixed. We want relative motions. Bearing gives the relative motions for the movement, and there is a bearing which is available there. They runs continuously. If you minutely change the design of the coach, the bearing will fail. You go and ask any railway engineer person, they don't play with that. The design is such a way created the bearing will sustain for a longer period of time. We know that train from the Mumbai Guwahati, they require 72 hours or more than that. It has to run continuously. We never change the wheels. It runs continuously. So that is the major component. In real world application, if bearing fails, the whole system will collapse. That's why the people say that near about 45% machineries fail if a bearing fails. So that much the part is very critical and component is very critical. Next slide, please. So why the bearing is, it is one of the important part, because it supports and gives the relative motions between the different rotating parts. If you don't still understand, I will give the example. Everyone went to drink a sugar cane. उसाचा रस प्यायला जातो ना सगळेजण. There's a big machine. That person gives the rotation. There's a shaft. Bigger shaft is there. It goes and then it started rotating. There's a bearing who gives the relative motion over there. So that much, there are different wide applications. If you think that is the one of the important component. But what happened over the period of lifespan or over the period of time, the degradation starts, because it's a mechanical equipment, the degradation going to start, and that is the major component, causes the damage to the machinery. Then we have to take care. We have to take care for that. So for the financial losses and to save the human being, we need to predict in advance what is happened. For example, when I listen to the noise of the fan, I came to know that there is a fault in my fan, but it has started very early. Can I do early detection? That's why sensors are mounted very close to objects. That's why sensors are mounted very close to objects, so that they can sense the things and then can understand. Now just think, how many of you know the signal processing? Okay, no problem. When the fault comes, how the journey started in the fault? There is a rotation, tuck, tuck, tuck. If I say this is one round, that is one round of signal, a complete rotation. So in each rotation there is a normal thing, then there is a tuck sound. In rotation round, then there is a tuck sound. What do you think? When there is a sensor is mounted towards that position, what will happen? There is a normal signal trend, and again there is a normal signal. There is a peak, there is a normal signal. So that indicates it has to be normal, na? But when the peak comes, which means that there is a issue. That is when we hurt. But our sensor has to detect minute change in the value, whatever the signal is sensing. And the signal sensing nothing but it sends the numbers only in positive and negative directions. Or the amplitude value will be positive or negative. So what is the basic target, or what is the basic policy adopted? That condition based maintenance. So don't stop the complete plan and then do the activity. In runtime only you take a proper measures to control the damage, and we can have a better environment to do the maintenance of a particular equipment if an issue occurs. So next slide please. This is the general overview of artificial intelligence mechanism when anybody wants to understand. Normally what we do, we have that experimental setup, or we call as a machineries. Via sensor we will capture the data like that. So vibration sensor is like that. We will have that. Once we got the sensor, it's up to a artificial intelligence engineer how he will handle that data, because that signal, vibration signal, is also we call it as data, and it's a one-dimensional signal. I'm currently talking about one-dimensional signal. You can have multiple signals also. If you mount the sensors, if you have more than 2 sensors or 3 sensors, accordingly we will get the data. But right now we are talking about the one-dimensional sensor data. From that sensor data, either you can extract the features, feature extraction and selection can be done. Then you can do the classification. Now in artificial intelligence or in industrial, what we want, when the tuck sound comes, basically that will tell, okay, fault has occurred. After fault has occurred, how much time is remaining? That is called, as in industry we call as a remaining useful life. Now once the fault has occurred, how much remaining useful life is there for this component to survive? For our mobile phone, we get the warranty, right? 1 year warranty, 2 year warranty. Each product gets warranty. Yes or no? How they calculate that warranty? Any guess or any idea how the warranty is calculated? What is done in the studies, they have collected the data, significant amount of data, they done their studies, and based upon that they calculated that warranty period, that this much is the period for that it will survive on an average. So they did the analysis basically in the labs, or test analysis has been done, and based upon that they decide that this much is the product, the life cycle of this product. So that based upon that they give the warranty. So this is the general setup, basically a methodology. Once you got this data sense from the data, you apply the different technologies. So one is the first is the classification. After the classification, you have to do the remaining like useful calculations. Next slide, please. Now let us talk about the data. So if you are working on an industrial problem, and if you don't have the access to the industry directly, they don't permit. So you can have a simulation environment. That is the first thing. If you want to collect your own data. Second, if anybody has already collected data and kept in the public domain, you use it, and then you carry on your experiment or results analysis, and then you can test on a real-time environment. So we have 2 data sets which I like to show you over here to understand the things, how to set up the conditions. Also, if you wanted to set up the environment in your institute, so how to set up that thing. If you get a chance in the industry to collect the data, you are always welcome, but if not, then what type of an environment we can set up. So next slide please. So this is our first setup which is available in VJTI. We procure under TechUp2. This is the experimental setup basically, which is give us the rotatory machinery setups to be on a bearing. The machine cost is near about 50 lakhs, and we spend around 2 lakhs on the setup to collect the data. Now if you see, this whole setup has the data acquisition unit, laptop, sensors are mounted, the machinery is there. We can change the speed and the load of the machines, because a particular machine can in an industry work for the different operating conditions. Speed is different, load is different, everything is changing with respect to the application. So we have collected the data under different environments. So we have set up the conditions. Next slide, please. If you see, this is the bearing which runs in the lots of places. So this is one of the type of bearing. If you observe it properly in the figure number A, that is the inner part where the shaft goes, and then it starts to rotate. It has a internally, you can see there is a ball. There is a, we call it outer part is called as outer race or outer ring. Inner part is called as inner ring. We have a cage in between. In outer and inner part there is a cage which separates the ball and the other component from each other, and they rotate that thing. Now what do you mean by fault? A fault is nothing but a minute fault can occur. Now if you are doing the experiment at your home, at your institute, then what you can do, you can create your own fault. We brought the expert and we help us to create a different fault. So if you see this properly, we have created this 0.3 mm fault over there, and then we collected the data. So such a kind of an experimental setup you can design. Now how to set up an experimental data? That is the first question. So next slide, please. Can you go to back? One more. I'm talking about two things, two data set. Second data set, I'm talking about CWRU, that is Case Western Reserve University, which has provided. We have studied that data set, and based upon that we took the decision that now we can, because that data set was collected in 2007, and when we collected, we are in 2017. There's a change has happened, drastic change has happened, and therefore we decided to collect our data set with the particular experimental setup, and we took the help of that data set. So next slide, please. Next. Okay, thank you. So if you see, this is our experimental setup. In collecting the data set, we need to decide sampling frequency. Sampling frequency is nothing but how much frequently you are going to collect the data. It's depend upon the type of application. So for example, if you are monitoring the temperature of Jalgaon city or over here, you are not going to per second, you are not going to collect the data. You possibly after 1 hour or in the morning, in the afternoon, in the evening you will collect, because application is not that much sensitive. But if you are at some machine or some nuclear plant, you have to collect the data continuously, you have to monitor that data. So why I'm talking about this, how frequently you should collect the data, because just think about that, you deploy the sensor in a particular location, it will throw the data. What do you mean by throwing? It will throw the data on a network. If you throw the data continuously on a network, the network congestion can occur. And not only that, our database will have a significant amount of data. So that is really useful. So depending on a type of application, we have to decide our sampling frequency, and then we have to collect our data. So that is the one of the important thing, and we decided 51,200 is our sampling rate. So we are going to collect 51,200 sample per second, and we collected that for 10 seconds under different conditions. So if you see this rotor speed and loads, we have varied that data set, and our power is that much. So these are the variation we did, and we collected for these 5 classes, different classes. And one of the important thing which was not there in the Case Western Reserve University, we added this fault, that is called as combined fault. It is not necessarily a single fault will come. In real world scenario, all faults can come together also. So therefore we include fault basically, and that is one of the major change in the Case Western Reserve University and our data set. That is the reason. Kindly go to the next slide. This is the Case Western Reserve University setup. They have this machine basically which has a bearing on both the sides, and they run the experiment, and they collected the data set on this experiment setup. Kindly go to the next slide, please. And they have this kind of an experimental setup. They collected the sampling frequency 12,000 and 48,000 for 10 seconds, and this is the speed variation 0, 1, 2, 3 power, and rotor speed 1797, 1772, 1752, and 1730. If you see this difference, the power difference is 4, and the speed difference 97 to 30, it is near about 67. Can you go to the previous slide, please? One more. What we did, we started from 600, we ended up to 2700. So the difference is 2400. The difference is very big. Not only that, the load difference is 35N. That is the another challenge we took, because it is not necessary we'll have that much ranges only. The machines are more complicated and they works in a different environment, so that's why we enhance the range also. That is the major reason why we collected that much data. Next slide please. Next. So if you have existing data, then also if you wanted to collect the new data, you should have a technical justification for that. That is the first thing. Then if you wanted to compare, if you see, we have compared the data set also, why we collected the data. So there's a variation in the speed as well as load. The gap between the highest and the lowest value is 2.004. Why? If you understand the signature, if your gap is very low, the variation in the speed signature is nothing but a one-dimensional data. Sometimes it is called as data, sometimes it is called as signature also. So signature difference is not that much significant. If you wanted to have a that much significant data, you collect a significant amount of data with a variation, large variation in the speed. So we did that thing. Then there's a significant variation in the load also we have found. And most important thing, we have collected the compound fault, which is not in the case of the case user universities. And that's why our data set is more complex. We have the significant ranges in the load and the speed, as well as the new type of fault which we added over there. So that is the major thing. Next slide please. No, next. Okay, so once you have data, there are three major things. If you go to the literature, people go with that. One, once you have a one-dimensional data set, convert to the image. If you think from AI point of view, some people convert to the image, that is the first task. Some people feed the raw data as it is. So this is the sample raw data. If you just see the peaks, basically a variation. So this is the sample data which we collected on our data, our machine. So one way of extracting the, any doubt? Okay. So one way of extracting the or converting your raw data into the image, so we have converted that thing in a image by using signal processing technique. So we got this kind of an images. So what type of an conversion you want to do, it's depend upon you. If you analyze the data set and based upon your type of data set, you do the conversion. So that is the first. Once you got the raw data, convert it into image, and then you apply the image techniques or image classifiers, basically which the classifier which understand the image properly. So that is the one approach. Next slide please. Now most important thing, whenever we convert our data set into image, how to get a confidence that we will achieve our experiment target. In this case, I'm talking about 5 faults and I wanted to classify them. Once I transform my raw data into the image, that is one of the type of feature, I will apply one of the technique that is called as TSNE, stochastic neighbor embedding techniques. Basically what it does, it transforms your image in a two-dimensional space. This is the two-dimensional space, and if you observe, this is the our data set and this is the Case Western Reserve Case Western Reserve University data set. You can observe 5 different clusters. I hope it is visible. 5 different, that gives us the confidence that whatever the conversion we have done from raw to image is proper. We will able to do the classification properly. I can now create a boundaries by a machine learning or deep learning technique, and I will able to classify that thing. So basic task is that whenever you do the transformation from one form to another, you have to verify by some techniques. So TSN is one of the form by which we can check whatever the transformation we are doing, we will achieve that thing, and this is the visual verification by which we got the confidence that now if we apply a technique, we will able to get a decision boundary, we'll complete our. This is for CWRU. So there are different techniques. This I have used. Basically whenever we transform the data into the image, we check TSNE embeddings so that we get a two-dimensional representation, and we get a confidence also that okay, we are in a direct proper direction. And if not, then we have to rethink about the transformation. Whatever transformation we have done, we have to rethink on a designing aspect, or we have to change that part. So next slide please. There is another way by which we can extract the feature, that is called as statistical features. This is there are different formulas people apply, like mean, median, skewness, kurtosis, moment generating function 0, 1, 2, 3, 4, whatever they are, and there are lots of things they apply. In time domain, some people go in a frequency domain, they have that value. So if one of the important thing, in previous cases we have the raw data in a single dimensional and we have that image, right? Can you go to previous slide please? One more. Thank you. A complete data set transform into the image, we have the image. Next slide please. One more. For example, this one of the formula is calculating the average. One dimensional data is given, I am calculating a single value. Average will give me the single value, right? Mean will give you a single value, yes or no? Right? A single value representation of a complete data set. What the single value tells us? This is the major difference between the image and the statistical value calculation. We have statistical formulas, we apply on data set and we get a single value from that. For example, if you consider the mean, what mean indicates? Anybody? What mean indicates? I know it's an average. Everyone knows how to calculate average, right? Or a mean, yes or no? Yes or no? Right? If you give the 5 number 10, 20, 30, 40, 50, or take 5 numbers as 10, 10, 10, 10, 10, what is an average? 10. But what that 10 indicates? I am over here taken only 5 values. Over there 51,200 values are there and I am calculating the mean for 51,200 values. For 51,200 values, there is one value now who is representing them. What that one value tells us? Are you getting my question? I hope so. Yes or no? I will give the real world scenario. We have elections. We have the Lok Sabha election, parliamentary elections, and possibly in Jalgaon district there is somebody who is member of parliament, right? Is elected. For that region, that one person is the member of parliament over there. Barabar na? Yes or no? What that one person indicates, if it is from the BJP or if it is from the Congress, possibly that constitutional people might favoring that party. Can we say it's a tendency towards that party because of that person has won that place? Agreed or not agreed? So if there are 1 lakh people, might be more than 50,000 people who has voted because of that person has won, which is belonging to that particular party, yes or no? So when we are talking about a single value, it indicates the tendency of that value towards that thing. That single value is very crucial, that representing the whole scenarios. And when application increase changes different values, but you will get a single value. So those are the single values basically. So that is another conversion. And based upon that, the statistical people try to work on that. Next slide, please. So if I have an image, why people go with the image? Because of the deep learning technique, a convolution neural network. You can directly feed to the convolution neural network and you are done. Because convolution neural network has solved the lots of image processing problem. They do the classification successfully 100%. So that is the one of the major reason why people transform the data to the images and then they apply straight away the deep learning convolution neural network technique and they are done. And they will get the proper output. Next slide please. So you can refer this work in this. So I have already published in a soft computing journal Spinner. You can refer that thing. Next slide please. Second, you can have the same thing, you can feed it to the machine learning technique. Same image you can feed it to the machine learning technique and you can get the output basically. Whatever the output you want, you can get it. That also we did it. If you working on a deep learning technique, what is the output? If you feed it that same data on a neural network, what is the output? Next slide please. This work is published in IEEE transaction. So 2019 it has been published in IEEE transaction, so you can refer that thing to thing also. Next slide please. If I have a statistical data, again I can create a classifier and then based upon that I can take an output. So one of the classifier we did is the meta learning is one of the technique. So different classifier learns the different things. What is the concept over here? That if I take a 5 peoples and I am currently delaying the talk, after the end of the talk, if I take a 5 peoples, their understanding will be different because they are different learners. Yes or no? Right now? So those are base learners. 1, 2, 3, 4, 5 peoples. their learning will be different because their capabilities are different. So therefore there is a set of base learners, and those set of base learners, if based upon that I created a metadata. Now if I combine all this together, possibly might be I will able to recollect the complete lecture about 95%, barabar na, or 99%. But if a single person is there, possibly 80% or 75%. Agreed? So therefore, if we have those groups, then we can strongly do that. So therefore, the statistical on a statistical data, we apply that meta learning technique and we do the classification for that. Next slide, please. So we published this thing in our 25th conference in CSCWD, IEEE in China, and the output was very satisfactory. Next slide, please. Now, why we talked about this? What is the reason? This all thing about collecting the data and analyzing the data. We want this at the end. Industry wants this. What is this? This is my machine behavior which I should see on my mobile. Integrated result. As a COE of a particular company, I want result on my mobile phone or on my tab for each and every machine. I will see how the machine data is and normal distribution, Poisson distribution of the data. So what is the distribution of the data we wanted to see? Then is any problem has occurred? So what type of a problem has occurred? So we wanted to classify our problem or our fault which is occur in a machine. If the problem has occurred, then we wanted to do regression analysis. What is regression analysis? That now how much remaining useful life is remaining for that machine, so that I can take a preemptive measures. So if you observe this thing, over there vertical green line, the fault has occurred and the machine can run up to this. So I have that much time to take a maintenance policy, adapt the maintenance policy and take a decision. So if you see, that was the normal curve, then it started to increase, expand exponentially. So once the fault occur, and then also you use that machine, it's going to fall down very quickly. So that is the trend. So I need to have that analysis, and then I'll get a health indicators basically. That is video. No. Yeah, play video. So let us talk about where this is useful. From the start, please.
Is a view on the transformation that's happening at GE right now.
From the start.
And specifically about one aspect of the technology called digital twin.
Bigger.
Thank you very much. Okay. Hi, good morning.
Zoom in.
I'd like to begin by thanking Admiral Han for this unique opportunity.
Just listen to this video for 15 minutes, then I will tell you what are the challenges now.
And what I'll walk you through is a view on the transformation that's happening at GE right now. And specifically about one aspect of the technology called digital twin. So you'll get a combination of two things. You'll get this notion of what this digital transformation means to a 125-year-old company. And you'll see how we apply it for specific technology that makes a significant difference. So let's start first with the motivation. What would move a company with 125 years in a certain direction? Well, there are two things. One is a stick, one is a carrot. So let's look at the stick. The stick is on the left side. So if you look at global productivity in the industries that we look at, especially those industries around energy, transportation, and healthcare, it significantly declined in the last 5 years, from 2011 to 2015. Significantly. What does that mean? In an environment in which every customer is asking for a decrease in price, because there's not a
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing in my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is Flex Start. Thank you.
Okay, good morning.
What you observe is the current scenario where the people are working. The person, what is digital twin? Digital twin is a virtual representation of an object which are in a real environment. We are creating a virtual or a software object, you can say, of a real world object, and based upon that we are predicting something. So over there was the big turbine machine again, for which a virtual environment has been created. That is why that is called as a digital twin concept. Twin of that machine in a software form, in a digital form, is created, and whatever changes is going to happen, that same changes is virtual environment will also see. That is the second thing. Whatever the damage is happening, the third thing, if you observe that he has told that fault has occurred. It was the era where people was collecting the data and they are identifying the faults by the experts. Now you want an automated system, artificial intelligence based system, that will tell that fault has occurred. Not only that, you have to show the location of the fault also, that where the fault has occurred. Once it has occurred, you have to tell the solution also, what are the solution we should adopt. If you see in the video, he has given the 2 options, option 1 and option 2. Second option he has chosen, for that he said you will able to save this much amount of money, and for that he has taken to learn same thing, he has taken the 125 other machine, similar machine, from which he has taken the data set which has a 15 years old data set, and based upon that he has conducted near about 60,000 simulations, and based upon that he shown the confidence about 95%, and this much amount of money. That is the concept what the industry now looking. That is called as digital twin. And I'm talking about the only one machine. Now, when we talked about the digital twin, saying in a words is very simple. Where is the need? Right now, this concept is on a, you can say it's a baby, and this is an upcoming concept. And up in future, everything will go in a digital twin. Not only the machines, but your buses, your trains, and any other objects can become a digital twin. For example, if you are traveling by a bus and there is a problem, your bus has to inform to the bus which is coming on the same route that there is an issue, you change the track. The information has to get transferred from one location to the another location. It was a very simple sentence, one bus giving the information to the another bus. But what is the communication protocol from the computer science perception? Because we need a networking protocols to transfer the information. Everyone will agree with that, right? So still there is a scope for the research. How you going to predict the things? There is a scope for the research. That what type of faults are occurring. Whatever discussion I have shown you, I have shown only on a bearing on a one component. And when I shown the flood side, there are lots of sensors. It is an integrated solution people want. They don't want for the bearing or a single component. They want for the integrated solution for the complete machine. That is their objective. And in a industry, there is no one machine, but there are n number of machines are there. And for n number of machine, you want an integrated solution. And I wanted to sit in my AC cabin. I am not going to move towards that machineries. I will sit in my AC cabin and on my mobile or on laptop, I will try to see the health and I will take a decision on those. And that is the digital twin concept basically. So I will model my whole thing in the another scenario. When I say I send information from one bus to another machine, you change the route. How two machines will communicate? We speak via English, Hindi or Marathi. We have that. And that language has a syntax and a semantics. Therefore, when I speak, you understand. Yes or no? So what will be the language of the communication between the two machines so that they can understand? Not only that, machine to human communication, how they going to happen? Because now there is a mind to the machine. The video says that mind plus machine. There is a mind to the machine. So how the communication between the machine and the man will happen, and the machine between the machine to machine will happen, so that they can transfer the information quickly and they can take a decision. For example, ambulance is going on highway, there is an accident, send the information, and that is something called a smart in the smart city or smart industry. And whatever where you apply, it becomes smart. You transfer the information quickly. So how to do that? You have to have a virtual object representation for that real world object. Same property has to preserve over there. Whatever the changes are happening, that has to be, and then you predict what is happening over there. And that is the digital twin technique. Kindly go ahead. Research scope or what industry needs.
What you saw just now was not a glimpse into the future. This is happening now, today. This is a representation of a D11 steam turbine that's currently running in Southern California. We call these representations digital twins. What you saw was an example of the human mind working with the mind of our machines. What's a digital twin? It's a living model that drives a business outcome. So this model gets data, gets operational data and environmental data, and constantly updates itself. It also can reach into the fleet, the 125 D11 turbines, and it acquires knowledge from them and learning from them, and it incorporates this into the model. And it uses this to drive business outcomes. It can drive outcomes like it can predict, or it can warn us and then predict failures to reduce maintenance cost and unplanned outages. It can give us the ability to optimize or provide mitigation events when we find out that we have these type of failures. And it can also allow us to forecast opportunities and actually benefit from these opportunities. So let me step back and actually walk you through what occurred in this digital twin in a very simplified way. So when you think about the twin, it really operates in three stages: see, think, and do. So in the seeing stage, and I'll relate this to what you saw previously, in the seeing stage, what it's doing, it's actually gathering data of its situation to give you a warning or prediction. This data that comes in is both operational data and environmental data. Operational data like the steam temperatures, the bowl temperatures, the rotor speeds. It takes that data in and it uses a model, that living model. This is a hybrid model of physical and digital capabilities. So it's a combination of metal fatigue, metal creep, Bayesian learning, and other machine learning techniques. And it uses this to create a cumulative damage understanding of what's happening on that rotor. As it does that, when it hits a threshold, it can then warn us there's a problem. It then can actually predict the problem. It also uses similarity learning techniques to reach into that fleet of 125 other D11s and gather their knowledge as well. So this is a model that's constantly updating itself to reflect the precise conditions of the asset and then learning from others in the fleet. After it does that, it has the ability to give us these insights at the right time. That's the first stage. And it does that through APM and using the digital thread to get all that data. The second stage is the think stage. This is when I ask the twin to give me options that I.
What he says, the first stage, that is seeing. When I talked about that, the turbine, I shown you the various sensors and we are collecting the data. Now we are talking about converting the whole turbine object into the digital one, which properties has to be preserved. Number of information has increased. Are you getting? I hope so. Initially we have actual turbines and the sensors are deployed and then we are capturing the data. Now over there we are converting the objects, and what is we are doing, whatever environmental effect or anything is happening on that, we are going to update that information. For example, if you take an electricity distribution transformer, everybody knows electricity distribution transformer at their houses, there were nearby. When it is new, it is in a good condition, but over the period of time the environmental condition happens, and because of that there is a changes happen inside that thing. Can we update that information? Can we update any other information which is operating or affecting that particular object? Any object, and that information has to done updated, and it has to be learned by digital twin. That system has to understand that thing. So he will see via sensors and he will update that information. Continue.
Could pursue. To do that, it ran simulations. Over 58,000 simulations, running them on the Predix platform, as Harel described in the cloud on those edge boxes. It's looking at historical data, it's looking at fleet data, it's looking at lifing models, it's looking at forecasts for revenue and cost. And it's giving you a number of options. It then reasons across the option based upon the risk and confidence that it can deliver. And with that, it delivered us two options. One that was manual, and one that could be delivered by an application that would run on a control system on the edge, exactly as described before. Now we get to the do stage.
Stop.
The do stage.
So what the expert has said about the second thing, we have, once you got the data, you done the learning, you have to think about the merge system has to think. Now it's just not a thinking from the, okay, classify the fault and you are done. No. It's a business model. We have to think from the money point of view, from the business point of view, how much we are getting and how much financially profit and financially loss to us. What are the things we need to do? What are the changes we should make? So might be a machine is running at high speed, because of that the issue was coming. So can I change the speed or the working conditions so that it can work properly? That is the basic objective for that. So whenever they are taking the decisions, they are not taking the decision on single data. They are collecting the huge amount of data. Those has to be go into the cloud computing environment. You should have big clouds and where you can save your data and then you do the processing. Not on a one single machine, but whatever the similar machines are there, and on a similar machine you take that data and you process that data, and then you go ahead with the optimization kind of thing. You run the bigger optimization things and then you get output. Continue.
Which is all about informing us and executing what needs to be done. So in option one, in the manual option, what you could do is you can have it prescribed to you What's the load rates, the ramp rates, the steam temperature that's needed for an operator to actually manually input. And all that is logged in APM and delivered to an operator to manually input. Or you can use an app downloaded to the edge, running analytics on the edge, one of those boxes you saw previously. Now that app can run much more precisely. It can precisely monitor the load and the ramp rates, aligning it with the steam temperature so that the thermal stresses on the rotor are minimal. That's how you get to that 25% reduction number. It also, by doing that, allows you to start a lot faster and burn less fuel. That's where you see the other benefits show up. All of this executing on an edge device. That's see, think, and do. These are the digital twins working.
Now the expert has said everything is running on edge. What do you mean by that? Whatever the decisions he's taking, the cyber physical system, whatever the capability has given to that edge computing, he has to take the decision over there only. He cannot has to go to the server or a cloud environment, take a decision and come back. It will take a time because we have to network communication will happen. For example, I'll give you the example for the edge devices. If consider there are a road is going on or there is a plus sign for the road. So on both the direction of plus sign is the traffic can go. And we have the automated signaling systems, and ambulance is very coming quickly. If I send that information from that location via sensor to the cloud and then comes, how much time it will take? But if I have an edge device which is capable of doing that, he will take a decision at that point. He will not throw the information to the cloud. He has to take a decision that on a priority you allow the ambulance to go ahead. I hope the example is very much clear. So in such a kind of a scenarios, the edge has to take the decision by his own rather than sending all information to upstairs. So that is the capability of edge devices. They have to tell that information that what is happening. They have to take the decision with respect to the machine from the financial perspective also, and then throw the information ahead. Continue.
With us, with the minds of the machines, creating these capabilities. Now, what if I wanted to go in a much more immersive environment and have the twin help me understand the problem? How about I use one of these Microsoft HoloLens, which I suddenly found here. So what I'm going to do is I'm actually going to use this lens to get a much more immersive environment. So what we would normally do is we would normally go into the actual physical plant and look at the steam turbine itself, the physical steam turbine. And from that physical steam turbine, what I would do there, let's make sure we get this to go. Right, what I would do there is I would overlay all of my digital capabilities on the physical asset, seeing exactly where the damage was occurring. Now, as I can't do that, I can't take us all on that journey, it's 6 hours away. What I'll do is I'll ask the twin to bring that to us, take the exact CAD dimensions of the asset from manufacturing and maintenance, and simulate it in this environment. All right? Now, as it begins to do that, right, you'll see the steam turbine appear. And it should be appearing any second now. Or is it one of these usual glitches when you do these things that you see appearing? All right, might be a glitch. There it is, in the audience. Now I can have the twin open the steam turbine. Okay, that didn't work. Twin, open the steam turbine. Let's see if that works better. All right, let's use the hand gesture. Okay, give it a second here.
Yeah, stop.
Ah, okay.
Now, The next scope for research in the industry, this is called as virtual reality and augmented reality. As we said, digital twin is nothing but the transformation of real world object in a virtual object. So whatever the glasses has expert use, that is the virtual reality glasses by which we able to see this virtual environment. And this is the representation for that. So this is the scope where the virtual reality and augmented reality will come into the picture. And now instead of viewing or going physically to see the object thing, by digital twin concept we will able to see his representation, and whatever the health conditioning or what is the environment in which it is working and what is the current condition or situation of the machine we can observe. That is the fundamental concept. So in the virtual reality environment, we can simulate the complete environment as per our application or the point of view, and then we can show what is happening. So that is the another thing which we want from the digital twin perspective. Continue. So if you see this video
Twin,
further,
show me
if you see where is the here,
where the
so it's
where
showing that information.
is. Twin, show me the length of the where and plot a baseline for
See,
me
this
so
is
I
the
can
remaining
see if
useful
we did
life,
no
which is the
mitigation
twin
what
is
that would
showing.
be.
So it has exponentially grown. One important thing that expert is talking
Okay,
in
twin,
English and the machine is understanding.
close the steam
Right
turbine.
now, human to machine communication is happening, but later stage the machine to machine communication will happen.
Now this thing is still floating around.
Stop.
What you
So this is, we are talking about only one machine. They have nearby 5,000 machines which are currently running, and they are monitoring those machines in a digital twin concept. Another advantage is that we can test the model before we launch because it's a virtual reality, it's not actual. So by the virtual reality we can test that that model in a virtual environment, and then we can launch that thing. That is another advantage. So this is what the next industry which is going to talk about, that is smart city or smart society or smart industry. What are the smart which go in these the my machine to transfer the information. With this, I will stop. I hope you have enjoyed the session. So if you have any doubt, you can ask. We are currently working on this. We started working on digital twins with our students because we already done the earlier part. Whatever the part is there, we done with that. So we are now transforming our models into the digital twins. We started with our students basically. I started with that. So possibly we will come up with our own digital twin next year with our students. That is our target. So when if you want to do, you do it on a small scale. What we are doing on a small scale. We are developing a prototype, a small prototype, and then we will develop a complex model on the top of that. We are not going. Kindly note that when I was in IC Bangalore, my professor told that you should start with the small prototype and then you enhance your prototype. Don't go with the larger scale. You should take a very small problem, develop a small prototype, and then around that you develop. That is the one of the techniques, divide and conquer technique basically. So you have sub problems, you solve that sub problem, and you get a solution for that. So we are working on a small module, and we are targeting a small module for one twin next year, possibly in the month of May. That is our target. So that is the industry need basically now. So therefore, the virtual reality, augmented reality come into the picture. Industry 4.0 need a communication protocol because they don't have a communication protocol, and this complex data set. Therefore, the cloud computing came into the picture, and how much we should process on a cloud, how much we process on our edge. That we have to, as a designer, we have to decide, and which kind of a decision we should take a locally and we should take a globally. That also need to be decided, and therefore we require a significant amount of data. The industry is spending huge amount of money on this. That is the one of the reason why this digital twin come into the picture. And in the future, lots of objects are going to change. People are developing the virtual world also. Massively, lots of students are aware of that thing. The virtual worlds people are developing by the augmented reality. So that is the upcoming technologies. People are talking about that. If you have any question, you can free to ask. Yeah. Machine learning technique, when we talked about the machine learning or deep learning technique, there is no thumb rule. Sit down, chap. There is no thumb rule that you got this data and you use this machine learning technique. There is no thumb rule. Like you go to the tailor and you give your measurement and he will teach us the cookers for you. No. First of all, whenever we wanted to work with the machine learning or deep learning technique or data analytics, we need to understand our own data. If you are working on a health data, first of all, you need a domain expert. You sit with him, you understand that data. When I started with that, I sat along with the mechanical experts. One is from our institute, one from IIT Jodhpur, Professor Sandeep Kumar Yadav. And then I understood the whole process. And then I understood what is my part as a computer engineer. Then I played my part from the machine learning point of view. Whenever you get any data or any application, understand the data property, initial pre-processing we call it as, and then you try to understand which kind of a machine learning technique can be suitable. Each and every, for example, if you take a decision tree, everybody is aware of that thing. Decision tree works beautifully on the discrete value. It cannot work on a continuous. You have to convert that continuous value to discrete, then it will work. So type of application, complexity, depending upon that, you have to decide which type of machine learning algorithm you use. Generally, people go with the deep learning technique straight away, but it is not necessary always the deep learning technique will run, because deep learning technique requires the significant amount of resources, computing resources, and if you don't have, then how you will run the model? Then you have to work with the machine learning techniques. So there is no thumb rule. With respect to your data set, you have to find out which model is suitable for your technique, and then you use it. I hope I have answered your query. Any other question? This required, see, if you observe this application properly again, the person has a tab, so it's a GUI, so you need to have one app need to be developed, or you give on a web browser. You have to develop that thing, because that information should be presented to end user. Internally, for machine learning or predicting something, you should know Python techniques or any technique you can use it, and then you prediction can be done. Then you should have a knowledge about the cloud computing, because you need to get connected with the API, because if something is installed somewhere and from there I'm capturing that information that has to get stored into the cloud, I need to write APIs to transfer my data from the cloud. So for example, I have deployed my sensor in agriculture places, then from that agriculture places I need to transform the cloud, so I need to have that thing. Then over the cloud, I need to run my program so that it will give me the analysis. I should store and I should do the analysis, and then I update my digital twin also simultaneously. So there are two ways communication continuously has to happen. So Python program is required, API writing in for the communication channel you required, for the developing the GUI part you require the JavaScript or something other programming languages. So there are lots of programming languages depending upon the type of app type where you are focusing. If you are talking about machine to machine communication, then in deep learning you need a natural language processing techniques, because NLP is a technique which allows us to do the communication, so you require that thing. But most of the time, if you go with the AI we can work on the Python. The Python has a big support, so you can go with the Python. Any other question? Yeah, this is one important aspect, that when I say transferring the data from one location to another location, or from that particular object to on a cloud, the security is a major concern. Over in this scenario, we have not talked about security. We are only talked about the development of application. The security is very crucial, because when you transfer the data, the changing in the value will cause the damage, because we said that the object is a virtual representation of that, and it has to be preserved. So we have to use the different security techniques depending upon the type of data we are transforming. If it is very critical, we need a very sensitive technique. So again, there is no thumb rule. You use this technique and you will preserve, because lots of techniques over the period of time has came, and they got vulnerable also. They were able to attack on that, or they able to crack those things. So there is no fixed techniques, but we require a security. That is the sure thing for the communication when you transfer the data on a cloud. Otherwise, your real world environment will not have a proper virtual representation. It will cause the damage, and that is the one area where there is a research scope that we can say. Any other question? Actually, research the security is our next year target.
Once we develop the prototype, then we will do the attacks, various attacks, and that is our level 2 target basically on a large scale. Okay, thank you.
Thank you, sir, for sharing your views and thoughts with us. It was great hearing you.
Dear students, sessions are parallel going on in adjacent building also. So all the sessions are over. After that, all the delegates are coming here for panel discussion. So panel discussion, we will circulate one sheet to you. एक छोटा सा कागज आपके पास आएगा. If you have any doubt in your mind, write your questions there so that we will ask or moderator will ask the same question here. Okay, and delegate will try to answer your queries. So instead of discussing among yourself, just write your query in any language, Hindi, English, Marathi, जो भी panel को समझ में आएगा, and based on that your queries will be answered. Okay, and please maintain the discipline. Last, please, it is your event, it is your departmental event. So if you maintain discipline, then that is your department dignity. I think this is enough for you. So wait for 10 minutes. All the people are coming here. Thank you.